And we are going to be recording today's webinar. It will be posted for view. However, participants are unable to get nutrient management credits by watching the recording. You have to be present here today to receive the nutrient management credits. So let's get started. We're going to talk about best practices for successful manure sampling and manure spreader calibration. This presentation was developed using materials created by Rob Minen. Most of you probably know Rob, and his email address is there in case you wanted to reach out to him for any reason. And so now is the time. If you are ACAP 38 nutrient management certified, we would like to do a continuing education credit check-in. So please take a moment to enter your name, your certification number, and your email address into the chat. Awesome. Those are starting to come in. That's great. And then we will do that check-in again at the end of the meeting. So make sure you stick around till the end for that check-in so that then you can definitely get the nutrient management credit that is being offered today. As I'm going through my presentation, if you have any questions or comments, feel free to put them in the chat, raise your hand, anything like that. I don't even know if I have a Q&A box down here. If there is a Q&A, you can put them in there. If not, just throw everything in the chat. Greatly appreciated, everybody. So, book values only get us so far, right? Like, book values are great. We use them in planning. We use them to help us, know we're in the right ballpark. But again, book values only get us so far. And so it's really important to consider manure sampling and then manure spreader calibration to really help accurately provide the information that we need. And really, the thing that I always like to mention is economics. Economics are so important, and I think sometimes we don't talk about them as much because that's not really what we do or why we're here. But thinking about working with farmers and agricultural producers, economics really are important. And so, if we're over applying manure because our sample manure test results are not accurate or our spreader is not calibrated properly, that manure could be used somewhere else on that farm, which would decrease the need maybe to be buying fertilizer for a certain area. And also over applying manure, of course, is very environmentally risky and something that is not recommended ever whatsoever. But on the other side of that is sometimes we're actually under applying our nutrients. And this is going to decrease the yield potential of the farm. It can cause the need for supplemental fertilizer to be purchased. And then we're not using those resources efficiently. And I think sometimes by explaining the economics, even mentioning money to a farmer can really help to get them invested in the process and the thing that we're trying to do, and to help make it easier for you as a nutrient management planner, as a ag technician, as somebody working with farmers. Like, sometimes talking economics can really help to solidify the reasons why we do some of the things that we do. And so let's talk about manure sampling. And there is a fact sheet on the extension website on manure sampling. And so I really am just kind of covering some key things from this fact sheet here. And we're going to get that link into the chat. Chris just did it for me. Thank you, Chris. I appreciate that. So if you haven't seen this, it is on the nutrient management ACAP 38 site that Penn State Extension has. So we're going to talk through some of those things. And really, why do we test manure? There's lots of reasons, and variation is a really big part of that. And so you can see here from, these two charts, these are dairy manure test results. And yes, on average, we're getting 27 pounds per 1,000 gallons of nitrogen, but that range is almost 0 to 60. And there is such a huge range in our manure analysis that our manure can vary so greatly. And so having an accurate test result really can make a huge difference in our crop production and for our planning purposes too. And also thinking about not just the variation in what's coming out of the cow, but then, where it's being stored, how it's being stored, what's the weather, is there a crust, what's the solids content. And so this other slide shows from 0 loads up to 200 loads, the variation in percent solids or pounds of nitrogen per ton. And so there is, really a great variation just in that unloading of the manure storage too, depending on agitation and, all of these other factors, that we can get a lot of variation in the actual manure nutrients that are going out onto the farm. And this was another one I found interesting. It's talking about, settled solids, really that variation from the beginning loads to the end loads and how the nutrients vary. But the thing that really got me was this chart talking about how much phosphorus is in the manure of these loads. And so you can see the breakdown, in loads 160 to 180, 39% of the phosphorus was in that manure. So the total phosphorus, 39% of it was in those loads of manure. And so there's such variation in how much nutrients are in different loads. And so, looking down here at the bottom, loads 5 to 100 had 13% of all the total phosphorus. In 58% of the manure was only 13% of the phosphorus. And so there's seeing this data, I think, really just helps to cement the importance of, taking the samples, taking them accurately and throughout that process, but also considering where the manure is being placed as we work through this. And again, this is just another example of that data. This is from a different set of research. But if you remove the first sample and you remove the last sample, 37% of the phosphorus was in 16% of the manure. And so that's a lot of variability, because our first load out has 104 pounds per 1,000 gallons. But then the next subsequent loads, 5 through 160, they average only 18 pounds of phosphorus per 1,000 gallons. So there is just a lot of variation and variety. And these are things to take into consideration. And seeing the data and having the data that's really showing that variation, I think, is really helpful to get the wheel spinning and get you thinking about some of these topics. And really, there's a lot of impact to where are we putting the manure then? And this goes above and beyond our manure management planning, but something to even talk to the farmers about, which loads go where. And so looking back at that data, the first couple loads had really high phosphorus. And so they would be great to be put on those low phosphorus test soils, or on areas with no steep slopes, areas where we're not susceptible to flooding or standing water, even areas where we have good ground cover or cover crop there. So thinking about, which field should receive which part of that unloading process can also really allow for some improvement in crop yield and manure use efficiency. So what is a good manure sampling protocol? And it's going to vary across different types of manure, different types of storages, different processes. But the optimal manure sampling protocol is going to be sampling while loading the spreader. So the best, most accurate samples that you can get are while the spreader is being loaded. And you're going to want to collect at least 10 equal-sized subsamples, and you're going to put them in a clean bucket. Clean bucket is very key here. We want to make sure our buckets are clean, not just to make sure our sample is clean, but also for biosecurity purposes. We don't want to be taking dirty manure buckets to various farms. Of course, more samples are better, right? The more subsamples you collect into that bucket, the better. You can do it every so many loads. Nobody wants to be collecting 200 subsamples if they don't have to. So, figure out a time, a scale, a number, like I'm going to collect every 5 loads or every 7 loads. That can be helpful. You want to make sure that you're avoiding atypical manure. So think about agitation that occurs, how long it takes to agitate. If you've got a section of manure that's coming out and it's thicker, it's got straw, hay, it looks different than the rest of the manure that you've been taking subsamples for. We want to avoid that. So we want to think about, like, if we're going to try and capture the whole tank, we need as many subsamples as possible. And even thinking about soil testing, anybody that's done soil testing, right? We avoid those atypical areas. It's the same thing with our manure. And then after we have all of our subsamples in that bucket, we want to thoroughly mix that, because our liquid and solids that are in our manure will start to settle out as we take these subsamples throughout the day, because we know this doesn't happen in 20 minutes. This process takes a long time throughout that day. And then, of course, we want to put them into the labeled lab container so that we know exactly what we are putting into the container that's going to the lab and sending it off. Now, this is optimal manure sampling protocol, right? When are things actually optimal? Hopefully you all laughed a little bit, because really things are never optimal in this day and age. And in the real world, on the real farm, things are never optimal. And so there are some best practices that we can follow to hopefully ensure we're getting as best of a sample as possible. And so that really is the key. The samples should be representative of what is being applied. And a composite sample is going to be best. We want to be taking this sample during removal and application of the manure. These samples aren't going to affect the application that is currently happening, but it's going to provide us that history to really improve our applications in the future. And of course, it's so much easier to sample during application than directly from storage, especially when we're looking to get a composite that is representative of that whole situation. And if you're working with liquid manure, has thorough agitation occurred? And thorough agitation is key there. How long do you think it takes to mix a liquid manure tank? If anybody has any guesses, put that in the chat. Nobody's guessing. All right, fair enough. So let's talk about solid manure for a little bit while you think about liquid manure and how long the tank should be agitated. So again, with solid manure, we want to be sampling during the loading or spreading process. We want to avoid direct sampling from a bedded pack or stockpile. And we want to collect samples from the beginning, middle, and end of the process. A minimum of 5 samples, but really 10 is better. We want to be aiming for 10. The fact sheet says 5, but in reality, aiming for 10 is so much better. And we want to sample this per the storage type that we are emptying. So thinking about our solid manure, if we have a heifer bedded pack and we have a steer bedded area, we want to be sampling per storage that we are emptying and sending off separate samples. We don't want to be sending one sample for the whole farm for all the manure group. And we want to make sure that we are thoroughly mixing those sub samples before we put them together and send them off. So loading and spreading is the best option for sampling, right? This is when we want to be doing this. We want to collect at least 5, but 10 is better, equally sized samples. We want to avoid large bedding chunks. We want to place these samples in a clean bucket. And then with solid manure, it's going to be better to actually mix that on a tarp or plywood or clean concrete, something that you can actually dump that solid manure out of that bucket and really mix it up well. And then take a composite subsample from that you have mixed thoroughly after, loading and spreading is done. However, not all operations load and spread at one time of the year. Sometimes they daily haul, right? And so that manure analysis can vary depending on the time of year, what those animals are being fed. And so throughout the year, if you can take 4 to 5 samples under the barn cleaner and repeat that throughout the year, multiple times throughout the seasons, that would be preferable to really get you an understanding of what that variability is in the manure. And it is really not preferred to sample a stockpile, right? Because thinking about a giant pile of manure, there's so many environmental effects that can mess with the nutrient analysis. I'm thinking about a weathered surface, if it's been sitting in water, that variation in what the animals have eaten. And so if you have to sample a stockpile, it's recommended to take 10 to 20 samples that are at least 18 inches deep. And again, we're trying to avoid that weathered surface and any of those atypical areas, and then mixing that stockpile sample thoroughly. But again, that is really not a best practice, but sometimes we have to do what we have to do, right? Because nothing is ever optimal. I don't know if any of you are sampling poultry litter in the house. Hopefully not, because we don't want to be going into poultry houses anytime soon. But again, the nutrients are going to vary across the house greatly. And so you're going to want to sample, each area separately, depending on what is happening, if the birds are being brooded or if they're being raised out. So you want to separate those areas separately. You want to, again, collect 15 to 20 probe samples. You want to look and see where the water and the feeders are, because the birds are going to spend more time in those areas. And so a lot of times we'll have higher concentrations of nutrients and moisture in those areas. So we want to, really look at that whole area and sample those proportionately. And then again, mix everything thoroughly and take that composite sample to send out to the lab. With liquid manure, said it depends on the size of the tank on how long it is agitated, would be my guess. And I appreciate your response in the chat for that. So agitation should, it should be 2 to 4 plus hours at a minimum. It's a long process and it's a continual process, because we know that manure is going to separate itself out. It's going to stratify without that agitation. We're going to end up with solids. So phosphorus is going to be towards the bottom with the solids, and then our more liquids and our nitrogen and our potassium are going to be at the top, just because of the magic of science and how, heavy things sink and lighter things rise to the top. And so stratification is going to occur. And with our liquid manure storages, of course, the best time to sample is during emptying, right? Once that agitation has thoroughly occurred and we are actually emptying that liquid manure storage. So again, we want to thoroughly agitate before sampling, collect at least 5, but 10 is better samples during that emptying process. And 10 is not even the best, right? 5 is the minimum, 10 is better, but even more than that is even better. We want to combine and mix thoroughly. And you're going to want to store those samples on ice if you are having to sample over several hours. And we know that emptying a manure storage can take a really long time. And so it might be helpful to have a cooler that keep those subsamples in until you're ready to combine and mix thoroughly and create a composite sample to be sent off to the lab, because we want to keep them on ice, keep them cool. And so spreading samples can reflect crop available ammonia. And with the variety of nutrients that are available in the manure and at that time that it's being spread, it's important to have such a good compilation so that you better understand how many nutrients are actually being put out onto the field and helping those crops grow. If you have to sample that liquid manure storage directly when it's not being unloaded, know that this is way less accurate. You should still have that storage agitated thoroughly to really kind of break up that stratification. Again, you want to collect at minimum 5 samples. 10 is better, more is best, from different locations in that storage. You want to combine and mix them together and then take that composite sample. And again, we want to keep that liquid manure cool. We don't want to allow it to get too hot during the day while we're waiting to send it off to the lab, so store on ice if needed. We want to send samples to a reputable lab. We want to keep those samples reasonably cool. We want to pack them into the containers provided by the lab. We got to leave a little bit of airspace, right? Because what happens to manure under pressure? You know, manure is biologically active. Things are happening. Bacteria is doing its business. Gases are being released, right? And so we want to make sure there's some airspace in that container so that there is room for expansion of gases. And then we want to get that sample to the lab as soon as possible. So I just wanted to mention, most of you are probably aware of this, but the Penn State Ag Analytical Services Lab, they do offer standard manure tests. And so, you know, if you're never sure where to send to, this is one option, but there are lots of other manure testing labs out there that you can send samples off to. And you want to record the details of your manure sampling procedures, because sometimes our manure test results might come back. We might look at them and say, this doesn't make sense, or this isn't what I was expecting. And so having records, the procedures that were followed while sampling, how much agitation occurred before that tank started to be emptied. Did agitation continue while emptying was happening? How were we removing the manure? Was it a liquid tank being emptied? Was it bedded pack and skid loader loads were being used to remove that manure? Was it being turned over into a stockpile? And how much of that storage was actually emptied? Because we know the top of that manure is going to have a lot different nutrients than the bottom of that storage. And so if we're constantly just taking off that top half, we're going to accumulate a lot of nutrients, and especially phosphorus, in that lower part of that storage. And if we're not ever emptying it completely, we can really end up with a buildup of nutrients in so making for a very nutrient dense manure when we do end up emptying out the storage completely. And so if there are any questions on manure sampling, now would be the time. Feel free to, put those in the chat, raise your hand and unmute. You can always ask those questions. Chris just threw the link for the Ag Analytical Services Lab into the chat. If anybody, wants to check them out for more information, you can do that. But in the short term, we're going to continue on and we're going to talk about manure spreader calibration. And so again, there's a fact sheet on this, right? Part of the nutrient management program. This is the manure spreader calibration fact sheet. And so we're going to go through a few things that are from this fact sheet here in this presentation. And so why do we have to calibrate? Why should we be calibrating our manure equipment? Well, it has a lot to do with our application rates. And so we're planning manure application rates. Really, that's the key of our manure management planning. It's part of any of our nutrient management plans. And if we don't have properly calibrated equipment, all of that time and effort we put into planning really is pointless, because the rates that we're planning really aren't what is actually being applied out on the field. And so calibration equipment is really the only way that we can actually know how much manure is being applied on the field. And we want to also ensure that the rates that we are planning are realistic, practical, and actually obtainable by the farm. And this is going to vary, farm to farm, manure spreader to manure spreader, and tractor to tractor. There's a lot of variability, which is why calibrating with the equipment that's actually being used to do the manure application is essential. So calibration records are not required by Act 49, the Manure Hauler Broker, if you're familiar with that, or the manure, or with manure management plans, right? But calibration records are required by Act 38, the Nutrient Management Program. And so it is essential to document calibration for each commercial implement. So each type of spreader that's required if the farm is going to be using that equipment for any of the nutrients being applied as part of their nutrient management plan. And really, we want to document that the operation can apply the rates that are being recommended in that nutrient management plan. And so that's really the key for those calibration records is like, yeah, I might be planting 5,000 gallons per acre, but the farm is not capable of applying that. And so application rates may need to be adjusted to meet the needs and the realisticness of the equipment. So our goals for manure spreader calibration are going to be to determine the effective swath width. So basically how far apart each pass should be with that manure spreader. We want to optimize the uniformity of the distribution of manure and then determine those realistic application rates. So tons or gallons per acre applied at a given setup. So tractor, gear, and speed. Those types of things are important so that we can hopefully replicate those results in the future. Swath width. This is the distribution from a spreader. It's typically going to resemble a triangle, and we're going to see, of course, that our rate decreases as we spread out that manure in that spreader path. And the further we get from that middle, the less the rate is. And that's why understanding what our effective swath width is. So if our goal is to apply 4 tons per acre, we can see that at some point, we're no longer applying 4 tons per acre. And so we need to consider overlap in that process so that we can get the average, or so that the whole field is getting on average 4 tons per acre. And so the effective swath width is basically the distance between the 2 successful passes of the center line of the spreader. So this is helping us to understand with our spreader path, how much overlap do we need? And if we have too much overlap or underlap, we can really see a variability in our crop production because our manure nutrients are not being applied evenly across the field. So thinking just a little bit about effective swath width and overlap, it's going to depend a lot on the spreader distribution pattern. And so different spreaders will have different types of distribution patterns. And a lot of that information can be found, it's included in the equipment manuals, the information about the equipment. It's going to talk about these types of things, but we also need to be paying attention out in the field to see how does this look and are we getting the results that we actually want. And so half of our maximum application, that's where we're going to start to see that decrease in our application rate. And that's where we know that we need to have that overlap. So one of the ways that you can see that is really, you can see this out in the field too. You can see in pictures, you can look at the uniformity and the shape of that spreader pattern out on the field, and you can see where some overlap is occurring and areas where maybe overlap did not occur, because we're all humans, right? And sometimes we can't drive the tractor straight. And so sometimes we do miss areas of the field, but trying to really get things lined up appropriately and accurately applied is very helpful. And so do you think narrowing the distance between passes will result in more uniform application of nutrients or less uniform application of nutrients? What do you think? So I'm going to give my standard favorite answer that some of you probably have heard me say in the past. It depends, right? If you are too wide and you narrow that distance between passes, yes, we can get more uniform application. But if we are already narrow and then we narrow it even more, then we can actually get less uniformity in our application. So it really does depend. So narrowing to a point does result in more uniform applications. So let's talk about spreader calibration, right? There are numerous calibration methods out there. There are a variety of different ones. The fact sheet that we shared a little while ago has 3 different methods in it: the TARP method, the swath area method, and then the loads per field method. And so we're going to cover the first 2, the TARP method and the swath area method. So let's talk about the TARP method. This really is one of the more common methods out there. It's one that we can repeat frequently if we need to. It works really well with our dry manure or our solid manure or our dry poultry litter. And so you need some equipment to handle this, right? It does require a little bit of equipment. So you need a tarp or a plastic heavy sheet of some sort, something that's about 100 square feet. So that would be 10 by 10 would get us 100 square feet. We're going to want a tent pegs or long nails, scales, preferably, some sort of springs tension or platform scale, and then a bucket, which really is optional, but it does make weighing a tarp covered in manure a lot easier if you have a bucket for part of that process. And I recommend having multiple tarps, because if you can lay out multiple tarps throughout the field, the farmer can keep spreading manure while you're gathering up and weighing one of those tarps without you having to rush to get that tarp back out into the field for the second pass, because we got to do this more than once for accuracy. And so you want to make sure you know the exact surface area of the tarp or sheet that you're using. So that's pretty easy. We're going to measure our length times our width. And there is a form in that fact sheet that you can actually follow along and fill this out. So that makes it really easy. When you're out in the field, you don't have to remember all of the things that you have to do. There is a sheet that you can follow along and record that information. So then you want to weigh the empty tarp or plastic sheet. And if you're going to use the bucket, make sure you're weighing the bucket too. If you're going to just wrap up that tarp and put it in the bucket, weigh both. But we want to make sure that we know what the weight of those things are, the empty weight, the non-manured weight in pounds, and record that on the sheet. Then we're going to want to position that tarp out in the field where the manure is going to be spread. We want to place it far enough out into the field that the farmer and the tractor have time to get in gear and up to the desired speed that they would want to be at when they're applying manure. Highly recommend securing each corner of that tarp with a tent peg or a long nail. I don't think anybody wants to be chasing a tarp on a windy day out in the middle of the field, or go find a tarp that's blown away. Securing the corners of that tarp is a very useful thing to do. So we want the operator, the farmer, to spread the first pass of manure directly over the center of the tarp. And so again, at that normally driven speed when applying manure. And as the person conducting that calibration or verifying things, we want to note details of the operating conditions. What tractor gear are they in? What's the throttle speed? What is the PTO speed? Do we know the tractor speed? What spreader settings are being used? We want to have an accurate record of all of that. And then, we talked about overlap. And so we want to apply 2 additional passes, one on each side of that tarp. And we want to apply these passes at that normal spreader overlap spacing that is required. So at that point, we should have uniform spread manure across our tarp after those 3 passes. And so we want to remove the tarp and fold it up. Try not to spill any of that collected manure. You can either put the whole tarp and the bucket and the manure on the scale, or just the tarp and the manure, or just the bucket and the manure, whatever combination you're going to use. And then you want to weigh that, and you want to record that weight in pounds. And then there's a section on that sheet where you'll be able to subtract the empty tarp weight that you had recorded previously to get you the actual weight of collected manure in pounds. At this point, you can determine what the manure application rate is out on that field. So you basically divide the amount of the manure collected by the tarp area, so how many pounds, divided by that tarp area in square feet, and then you multiply by the value of 21.8. And so 21.8 is the conversion factor that was determined using, square feet in an acre and 2,000 pounds per ton. Multiplying it by that value, it will convert what you've collected into tons per acre. And so you can write down then on that sheet that application rate in tons per acre. And so we want to repeat this calibration procedure, preferably 2 more times, but at least 1 more time. Repetition is necessary to increase the reliability of the application rate and the reliability of our calibration. And so once you've done this, 3 times, hopefully, then you can calculate the average of each of those measured manure application rates and record that final calibrated rate in tons per acre on the sheet. And so this is what that sheet looks like. And so it shows you what's the surface area, what is our tractor speeds, what is the empty weight of our tarp and our bucket, gross weight with the manure. We do the subtraction. It tells you that 21.8. You don't have to remember that conversion factor. It's listed right there. And then it's nice because it gives you for 3 times, 3 options, those 3 trials, 3 attempts, 3 calibrations that we want to do. And then you can average those together and record that final calibrated application rate. And then this can be used as that record that goes in with that 38 plan, or, given back to the farmer for any of the other manure plans they may have for their records. So we're going to get into the swath area method. And so the swath or load area method requires a little bit less equipment. All you need is a measuring wheel, but you do have to determine the spreader capacity first. And it does, I think, take a little bit more time too. And so we need to determine the spreader capacity. And this could be from, if there's an operation that has scales, you weigh the spreader empty, fill it, weigh it full. That will tell us what the spreader's capacity is. There are calculations that you can do to figure out the spreader volume. And in that fact sheet, it really talks about different shapes and designs and calculating spreader volume, or using the manufacturer's rating. So hopefully the manufacturer says that XYZ spreader has a capacity of this. Now that's going to be more helpful probably with liquid manures than with solid manures, because we know with our solid manures, we need weight, and weight can vary dramatically based on how wet that manure is. But once you figured out approximately what that spreader capacity is, you want to record that, whether that's manure in gallons or manure in tons. Then you want to load the spreader consistent with how they would normally load it and to its capacity. So if we want to make sure, if we're using a liquid spreader, that we're filling it to capacity when we're going out to do this type of calibration. And then we want the operator, the farmer, to spread 1 full load of manure in a rectangular pattern. And that rectangular pattern just makes things easier for you. And so we also want to note settings. So again, tractor gear, throttle settings, PTO, speed, spreader settings, all of that. We want to make sure that we are noting those things as we're going through this process. So once that load has been spread, that whole load has been spread, you're going to measure the length and the width of the application coverage area. And so you're going to do this in feet. So this is why we need a calibration wheel. So you're going to walk out and measure the area of the field where the manure was actually spread. And that's why a rectangular pattern is helpful, because it just makes the math a lot easier, and you don't have to be trying to figure out triangles and extra pieces and sides and everything. And so there is an alternate method where you can figure out the application length using ground speed and the time it takes to make that application. But honestly, I think being able to actually go out and measure that can make it a lot easier, because one, not all tractors have speedometers, and sometimes our ground speed is not always the most accurate. So once you've measured that application size, you want to calculate the size of the coverage area. We can multiply the length by the width and divide it by the 43,560 square feet per acre. And then this will give us the area of coverage in acres. And so once we know the area of coverage in acres, and we know our spreader volume, what is the capacity of our spreader volume, we can divide that spreader volume by the acres covered, and this will give us our manure application rate in gallons or tons per acre. So again, we want to repeat this process one or two more, preferably two more times, right? We want to at least hit 3. 2 is better, 3 is best, because we are going to have a little bit of variation. And we want to calculate the average of each of those measured manure application rates, and then, combine those together, record the final calibrated rate in gallons or tons per acre. Again, there is a sheet, makes this so much easier. You don't have to remember all of these different steps from scratch. There's a form to fill out. And again, we want to document the spreader capacity. What rate are we using? What gear? What's the gate setting on the spreader? Measure that spread area width and length, calculate the area that's covered, divide that by our spreader capacity, and we end up with our application rate, and then average those all three together. And you have that record sheet that says this, and that again goes with the 38 nutrient management plan, or can be given back to the farmer and kept with all of their manure records, their manure management plan, things like that. Field edges can be complicated, right? So we don't always want to be measuring and doing our calibrations on our field edges. I know that sometimes that is the area where this is going to be occurring, but we want to think about our field edges, not just with manure calibration, but with manure applications also. So thinking about a lot of our field edges can be next to or even part of environmentally sensitive areas. They can be compacted, and so we're going to get a lot less productivity there. So those areas sometimes can be nutrient deficient. They may need more manure nutrients, and soil tests can help document that, but also they may have too many manure nutrients because they are less productive. And so soil tests can also help with that. So we want to think about our field edges in planning, because sometimes they are not always the most accurate representation. And again, when we're thinking about soil tests, we're doing a complete subsample. We want to avoid some of these environmentally sensitive edge areas, but sometimes we also need to test those separately, especially if there's been a repeated history of manure applied to those edges, but they're not part of our actual soil testing program at the farm. So in conclusion, manure management practices, there are core things that we need to consider when we are planning anything around manure, whether it's for manure management plan, NRCS 590, an ACAP 38 nutrient management plan. We want to be doing yield checks. We want to have soil testing and history of soil testing and repeating that with accurate sampling, manure testing, and spreader calibration, which we've already talked about today. All 4 of these practices should be part of a producer's manure management program. We know that those things are not always happening, but the more accurate the data, the more efficient the manure nutrients can be used and applied, which can ultimately lead to a savings in economics. And so I think that's really important, where we can help save money or allocate our nutrients in a much more appropriate, realistic, practical way out on the field. And calibration helps to ensure that all of our application rates are actually rates that we can apply out on the field. Work with the producer and the plan writer to match those application rates with the equipment. We want to use the swath area or the TART methods to document our equipment application capabilities. And once that has been done, I didn't cover the loads per field method, but it is in that fact sheet. But the loads per field method is a way to basically check and verify your calibrations that you have done previously. And so that's a way to, check the results and see if things are matching up. And so that's a really nice option. I did not talk about that, but if you want more information, feel free to reach out to me for more information on that method. I can talk through that with you. I'll put my email in the chat just in case you don't have it. Please enter your name, certification number, and email address into the chat for nutrient management CEC credits. Thank you all for coming.